Good afternoon and welcome to the fourth webinar of the Solar Show MENA series. Today's panel session will cover the importance of accurate and reliable solar data and measurements. We're delighted to be joined by Henrique Pereira, Senior Manager for Energy Services of RAC Municipality, Leandro Bento, the SVP of Operations for Yellow Door Energy, Asmay Aziou, Forecasting and Sites Prospecting Engineer from Mazen in Morocco, and Ian Colburn, who will be our moderator, who is an independent technical solar consultant based in Canada. So now I will hand over straight to Ian. Please, anyone who is watching the webinar, feel free to ask as many questions as you like in the Q&A section, and we will get to your questions throughout and at the end. So Ian, over to you.
Oh, hello, everybody. We're going to begin with an introduction. So each of the panelists is going to give a brief introduction of themselves. After that, each of the panelists has a small slide presentation to kick us off. The topic about data in solar, we feel like it really divides into two categories. One is the use of data to predict output, so modeling systems before they get built. The other half of the topic really is the use of data for monitoring on an ongoing basis what is going on with your PV project. And I think between the three panelists, we have both of these topics well covered. And after the presentations that each one does, we'll be looking carefully at your questions, and we hope that that will carry us through with some interesting discussion. So I'm going to just begin with Henrique. Henrique, could you please introduce yourself?
Sure, Ian. Thanks for the lovely introduction. Hello, everybody. So my name is Henrique. I work for RIM. RIM is essentially the energy agency for the Emirate of Ras Al Khaimah, and we are focusing in essentially implementing a strategy that will reduce the electricity and water usage in the Emirate and also increase the share of the renewables in the mix. So we will speak a little bit about what we are doing on this field of solar and the importance of data that it has for our activity also.
Great, thank you. Asmay, please introduce yourself. Asmay. Asmay, your microphone is muted.
Okay.
Good, thank you.
So thank you, Ian. Good morning or good afternoon, ladies and gentlemen. It's really a big pleasure for me to participate in this webinar entitled The Importance of Accurate and Reliable Solar Data and Measurements. So I am Asma Aziwi. I'm a forecasting and sites prospecting engineering. I am working at the Moroccan Agency for Sustainable Energy at the Site Exploration Department. So I contribute mainly in the renewable resource evaluation, forecasting and site prospection. So my department is involved early in the project development process. Thank you.
Good. Thank you, Asmay. Leandro, your turn. Please tell us about yourself.
First, thank you very much for the invitation. My name is Leandro Bento. I feel that I'm a lucky guy for being in this sector, in this amazing sector for the past 14 years. The first 10 years at Marti Fair Solar, one of the biggest EPC companies in Europe, where I got, I would say 90% of the knowledge about PV I have today. Then 2016, Marti Fair Solar got acquired by Voltalia, and I had the opportunity to learn more about the IPP part of the business. And last year, in January 2019, I joined Yellow Door as SVP operations to build the operations team and to help the company to grow and to to pursue the goals we have defined for the company. Thank you very much.
And Yellow Door is based where?
Yellow Door is a local company based in Dubai, in UAE. We have several affiliates. I will talk about that later on. I will make a brief presentation of the company. Okay.
Good. Thank you very much. Great. So we'll come back to the topic at hand, and we'll begin with Enrique. And so, as I said at the intro, we really divide data into two sections. One is measurement and verification data. The other is data that's used before a project gets built. Enrique is going to speak mainly about their use of data in measurement and verification and projects that are already up and running. Enrique.
Thanks, Ian. I will then share my presentation. So hopefully now everybody can see it. So I will just speak very shortly about the strategy that I spoke a little bit earlier about what we are doing here, and then focusing on the solar projects and what type of data we are using for these projects. So, so just a quick focus. So these energy efficiency and renewables strategy for the Emirate is part, of course, of a wider Vision 2030 that is being defined and updated, which is in itself in line with, of course, all of the UAE federal strategies in the different ranges, which are in turn aligned with these international standards. So just to give you quite an overview of what is the strategy is anchored in 9 different initiatives, as you see there. Compared to the baseline year of 2017, our goal up to 2040 is to achieve a reduction of electricity consumption, water, and also increase of renewables in the share. So I will kind of focus more this talk on this area. Just also as a context, so this of course is anchored on a set of enablers. I'm highlighting these because part of these enablers are also somehow, you know, related to what we are talking here. So a part of things like you know, awareness and financing and so forth, we have some innovative areas that we are bringing on, like for instance what you see here concerning solar readiness in our green building code regulations. So this is not in itself a solar project, but paves the way for making it easier to happen in the future. And this is anchored on data that we have been, of course, getting from many different projects and initiatives in the Emirates. And also the part of information systems, which is quite important for us. So we not only develop and implement these energy efficiency and renewables strategy, we are also responsible for doing what we call the M&V cycle of it. So we need to get data every year from the different initiatives that have been implemented, and we need to validate it against, you know, a model that will help us understand if the goals to 2040 are going to be achieved or not. So this is just as a brief context to highlight that data is always at the core of what we are doing. And of course, that is the same for the solar program that we are running. So I have chosen here to highlight just a few projects that are ongoing on the Emirate. I don't know if all of you are aware, but the Emirate is fed by a utility called FIWA. FIWA is a federal utility, so not a Emirate-wide utility like Dubai has with FIWA. So it is a little bit different context. We don't have a regulation yet published that allows us to do solar installations and connect it to the existing FIWA grid. So we are starting on doing some initial pilot projects, like the ones that you see there, one that we did in carports for our own headquarter buildings, and others that are ongoing in different facilities in the Emirate. We have, of course, a large pipeline of projects there. But I would like to focus now today on this particular project of our headquarters, just to highlight you the kind of data that we are getting from this project and the kind of data that is relevant to us. So of course, I've chosen just to put here a few sample points or charts, if you want to call it like that, that are automatically generated by the systems that are implemented in the solar carport that is installed here. So we managed to have a large number of data points that we get, and these are not only related to the, let's say, normal things like generation curves for instance, 1 week in this case, or 1 day in this case, but we have also chosen to require the implementation of a weather station that is dedicated to the project, because also quite important for us are things like irradiation levels, temperature levels, that then can lead us to assess things like what is the actual yields of the solar installation versus a kind of expectation that was there from the initial stages. So this is quite important to us. Of course, also important because there are contractual aspects that are attached to how well or is the solar installation performing, but also interesting to us because we want to always keep a very close eye on what's happening to understand, for instance, if there is any deviation that we need to react sooner, or if there are any unforeseen aspects that we can see from the data. Now, this, of course, is just a highlight, as I said. I think during this talk, we'll have opportunity to talk a little bit further into more details on the importance of data, in this case, for the solar projects. So I would stop here now for the time being, Ian, and I'll pass it back to you. And we can then go a little bit further when we have some doubts and questions from the audience.
Excellent. Thank you, Henrique. I already have some questions, some very interesting slides coming up there. Let's go next to Asme. So Asme is an engineer in Morocco. Her responsibility is more at the project planning stage to identify sites. And so she's going to speak about the use of data in forecasting PV output in her job in Morocco. Go ahead, Asme.
Can you hear me? Okay.
Yes,
thank you very much, Ian. So before starting, I want to just like to say that this presentation was jointly prepared with Mr. Amin Ammar, who is in charge of management of weather meteorological station and processing of related measurement data. So the outline of my presentation is as follows. So first of all, I will begin my presentation with an introduction to the topic. The second part will be devoted to the presentation of the Moroccan Solar Atlas. I will also expose the Mazen solar measurement system, and then of course I will give some concluding remarks. So actually, the current Moroccan energy policy aims to develop and promote renewable and clean energy. Therefore, Mazen was created in order to manage renewable energy in Morocco and lead development program of renewable energy integrated project aimed at creating 6,000 megawatt clean electricity capacity and to secure up to 52% of the country energy mix from renewable energy by 2030. So to this end, one of the Morocco's most available energies that could contribute appreciably to improve the national energy mix is, of course, solar energy. However, this solar radiation received at the ground level at a given moment is very variable, either temporal or spatial variability, and depends on a large number of parameters. So to this end, it is important as a developer to have a reliable and accurate solar resource database in order to master this variability. So accurate information on solar resource is a major importance during all the phases of the project life cycle. For the resource assessment at the first stage, for the elaboration of the solar atlas and the installation of the meteo station, in the technical conception phase, for choosing the appropriate configuration and the optimal technological design, also in the project financing for modeling the economic viability, and also in the operation and maintenance phase, in order to improve to improve the real-time monitoring of the installation and to have a better performance of the solar plant. So the design of the solar energy conversion system requires precise knowledge of the solar radiation at the installation based on the two principal supports, which is the satellite data and the in situ measurements. I will start with the Moroccan Atlas, which is based on satellite data. And what we do is we apply cloud cover. We use cloud cover images acquired by meteorological satellites used for the estimation of ground irradiance via conversions models. So those satellite data are inputs of models in order to establish the solar atlas. So if you want to explain more and to exploit what is the solar atlas, it is actually a series of average and monthly GHI and DNI solar irradiation maps of a high spatial resolution, which is 250 meters for Morocco. And it is, of course, an interactive decision support tool for the national energy strategies in terms of suitable site identification. And it serves also as a basis for energy policy planning. So for our case, the Moroccan Solar Atlas, as I said, had a special resolution of 250 meter as a temporal, as a special resolution, and the temporal resolution is 20. We have the historical data of 20 years of simulation, and graphical data is used for the GIS, the Geographical Information System, in order to choose the best site. And it is updated each 2 or 3 years. There is a problem is that sometimes modeled solar irradiance data issued from satellite imagery tend to underestimate or overestimate solar irradiance. It is also in this outlook that we should stretch the concept of calibration of this satellite data to ground measurement in order to quantify the solar resource in the most accurate and reliable way. Our solar atlas is available available online in order to popularize the use of solar data with the general public and make high quality data available for professionals and researchers. So move on to the last part, which is the punctual and the local site assessments based on the meteo station. So we have actually a fleet of 18 automatic met station, which measure a lot of parameters: DNI, GHI, the wind speed, the temperature, pressure, and precipitation. And it's of good accuracy. It's actually a secondary standard meteorological station, and with a lot with the system of the security and the maintenance and all the data processing that is done real time. So we have also implemented a management and supervision system for the fleet of the weather station. We can do it allows us to do the real-time data collection, the data processing and quality control, the preparation of all the daily and the monthly reports, and also all the graphs and the analysis that are useful for our team. So it's a screenshot of our supervision and management system. We also elaborate what we call the typical meteorological year. which require a high time resolution and long-term data. And we calibrate them with at least 1 year of concurrent measurement with the ground and the satellite. We use models suitable for adapting all this data, and this TMY is used by financiers to assess investment risks and profitability of solar projects. They are also inputs for simulation software in order to dimension and to size the solar plants and identify the weak points of the site and optimize all the system, all the whole system from data from a precise entry. So if you want to, we can say that actually the uncertainty in the estimation of the solar resource is one of the most important source of the global uncertainty of energy projects. So that's why actually doing a good resource assessment and having a good database will allow us to estimate with a reliable way the energy production and the output of the solar plants. It's around generally around 5 to 70% of the uncertainty of the production of the solar plants. I will say some words for the forecasting system that we have developed at Maven. So it really help us to estimate and forecast the solar energy, and it is really a good way in the exploitation of solar energy, which require a prior knowledge of the energy yields level to be reached, and it allows us also to increase the penetration rate of renewable energies by helping to anticipate the production by different sources. So Maven has developed an irradiation forecasting solution for GHI, DNI, GTI, and all other weather parameters in 3 time horizons: nowcasting, intraday, and day-ahead forecast. And for each time horizon correspond a methodology or approach. Like for nowcasting, we use the sky images and in situ measurements. For the intraday, we use satellite images, and for the day ahead, we use numerical weather prediction models. So as I said, at each time correspond a forecasting approach. And generally we can go from the nowcasting, which means from minutes to 8 days of time horizon. So this solution allows the provision of data, and also we have developed a user-friendly interface which allow to view and download forecast data, follow all the climatic and meteorological alerts. And we tested this solution on the 4 sites: Ouarzazate, Middle Kayoun, and Boujdour. So as a conclusion, we can say that of course the evaluation of the solar resource is a safe investment. It's and if we conduct a deep resource evaluation, that will lead us to a more accurate energy estimate and a better characterization of the project site, and we thereby reduce the project related risks. So thank you for your attention, and I will be pleased to answer to your question afterwards. Thank you, Ian.
Great, thank you so much, Esme. For participants, I see now we have 68 participants. That's fantastic. If you have questions, please type them into the Q&A. We are getting some good questions coming in now. We will address your questions in a few minutes. We're going to hear next from Leandro. Leandro is on the vendor side. So Leandro's company, the Yellow Door, is involved in developing commercial solar projects in the MENA region. And so Leandro is going to talk about data from his point of view. Go ahead, Leandro. Leandro, I'm not hearing you. Check your microphone, please.
Thank you, Ian.
Perfect.
Enrique, as my congratulations for your presentation. You were great. So I will briefly present Yellow Door, and then I'll jump directly to the topic of this webinar. So Yellow Door is a company founded in 2015 in UAE and Jordan. We act on the commercial industrial segment, and we have more than 100 megawatts of projects, solar projects. Our actual active countries are UAE and Jordan since the very beginning, since 2015. Last year we opened Pakistan, and this year we will open Saudi Arabia. I can say as well that last year we achieved a very important milestone. We raised a fund of $65 million with a set of very important shareholders, including IFC, Mitsui, Equinor, Apicorp, and Adinium. And it was important because this will leverage the growth path and the growth plans we have defined for the company. You can see some of the projects here. Of course, we have much more there. We have here Nestlé in UAE, Le Chocolat. We have Jabri and Classic Fashion in Jordan. We have also Umnia, Carrefour in Jordan. We have Starlet in Pakistan that we just signed, and we have another 2 projects for one of our shareholders, Apicorp in Saudi, one solar lease and one energy saving project. So talking briefly about what we offer to our clients, we offer a long-term contract where we guarantee the performance, and this is very important because it's directly linked to the topic of this webinar. The client have no upfront investment, and I would say the client have no investment at all, because we will build, we will operate the plant, so all the capex and opex will be on our side. The only thing the customer have to pay is for the services we are providing, for the energy we are providing while the power plant is operational. What are the benefits? The savings on the electricity bills from 15 to 40%, no upfront investment, and then the client can be focused on their main business, on their core business, and don't need to worry or to lose their time thinking on how can we save money on the energy bills. We are there to support on that side. Imagine that at the end of the lease, we hand over the solar power plant to our client, and he can benefit for another, I would say, 10, 15 years of completely free solar plant producing energy and reducing their consumption. This will enable and enhance their sustainability, work also on the corporate social responsibility, and we will, from the day one, work on the guaranteed performance so that they can have the benefit of the power plant. Okay, so jumping now to the topic. How important is data accuracy? I agree with Ian, and I think we are completely aligned. We cannot talk about data accuracy in the same way in different phases of the project. Data accuracy plays different roles in each of the phases. And for example, on the pre-construction phase, the focus is more on the system modeling. And here, the great presentation of Asma gave us a bit of the background on the meteorological data, a very important input for the system modeling. And on the post-construction phase, the focus is more on the data acquisition we are getting from the power plant, and the data analytics we can do with the data we are collecting, and we can use it, for example, to forecast or to retrofit the system with improvements. I will not talk about construction phase because we can assume that the construction we will reflect exactly what we designed on the pre-construction phase. So the construction will not enter any uncertainty to the process. If we go deeper and jump to the pre-construction phase, we see here two models. Okay, we have the financial model, and I would like to start from the end. The financial model is the tool we have to allow us to calculate and define the discount we can give to our customers. Keeping in mind that we have shareholders and lenders with requirements that we need to meet. So all the discounts must be calculated taking this in consideration. And then if we have a strong financial model, we need to have strong inputs as well. If the inputs are weak, for sure the results will be weak, and we won't be comfortable to provide the discounts or the rates we want to give to our customers. On the cost side, and that's why I spoke about the track record of the company. On the cost side, we are very much comfortable because we have a big track record that allow us to be very precise on the cost. Another aspect is the good relation we have and we maintain with our service providers and equipment suppliers that allow us to have very aggressive costs with very good terms and conditions. And if we join this together, we have the cash flow and the cost pretty much defined and very accurate. So we just need to look to the expected production. If we go to the expected production, this is directly linked to the revenue of the project. And we need to make sure we fine-tune here, because as Asma was speaking about, we cannot overpromise or underpromise. Otherwise, we will jeopardize the project. And the expected production is the input for the financial model, but is the output for the technical model. And if we go back and we see the technical model, the PVSys, I'm sure everyone in the market know what is PVSys. PVSys is a simulator that works as well as the inputs we put in the system. So if we have weak inputs, again, we will have weak outputs. So to have a very reliable expected production, we need to have very strong inputs. We can start on the equipment. Equipment, we have the models being provided by the suppliers. So it's equal for all the companies, okay? These are the OND files for the inverters or the PAN files for the modules. So no big deal here. Then we have the site specifications and the project assumptions. On the site specifications, if we have a very accurate design with a very good shading scene, with all the coefficients and factors well sized, I'm sure we won't have problems and the model will make its work in a good way. Then we just have meteo data there. And the meteorological data is where we need to pay more attention, because as we saw on the last presentation, is where we can have a lot of uncertainties. Okay, so we have, and I will speak more superficially about this meteo data. I think we had a great presentation on these. But for example, we have several meteorological databases available in the market. We have Meteonorm, we have NASA, we have SolarGIS. Personally, and in our company, we adopted SolarGIS as the most reliable database, because we are in the Middle East. If we were in Europe or in US, Meteonorm is very accurate there. I think outside of these regions, Solar GIS is the most accurate. And we use this database, and we can, for example, instead of monthly database, we can use hourly database to be more precise and to give clear instructions to the PVCs on the values we want.
Leandro, I'm just going to jump in for a moment. We are getting quite a few questions, and we'd like to have lots of time for that.
Okay.
So if you can move along, that would be great. It's very interesting what you're talking about.
Okay, I will spell that. So on the post-construction, we have the power plant working. So we are not modeling anything. We are just collecting the data, and we are collecting real production data and real meteorological data that we can cross-check. First, we need to run quality checks on the data we are collecting. Then we need to compare the data, the real data, with the expected one, with the one we use on our modules. And the data analytics team can work out the data to use on the forecast or to feedback the system, improving the assumptions we will have in the future projects, improving the models. Okay, for these, we need to have a very strong platform where we gather all the information, and this is a picture of our display wall in our operations room, where we collect all the data, where we work, we study. We have the O&M team, the data analytics team, exploring the data and studying the data and giving results. We are also working to provide a visual tool to our customers, as you can see, a Solar dashboard that allow them to see the performance of the systems. And I would just finish this presentation saying that if we guarantee the performance of a system, we need to make sure we have a strong and reliable model. As you see on the pre-construction, we need to put our focus on the meteorological database, and we are choosing just the very best in the market. Post-construction, the idea is we can learn a lot from the real data we are collecting from our systems, improving the models itself. And the big data is a great inspiration for our improvements. And I think everyone shared this thought as well. So that's all from my side. Thank you very much.
Excellent. Thank you so much, Leandro. I can see, we can see really clearly that data is absolutely critical to your business model. If you have data that's not right, your profitability is just not going to happen as you're in the business of selling the electricity as opposed to developing the projects for a customer. So, yep, I think you're well positioned to answer some questions. Leandro, if you can unshare your screen, that would be great. Thank you. Good. So I'm going to jump to some of the questions that are coming in from the group right now. Some of them are are very interesting questions, but a little bit off topic. We'll see if we can deal with those in due course, but we'll start with the ones that are really right on. Question, Asme, for you in Morocco. This person is asking, is there a way that you can consider climate change parameters as you look at your data? And I think the sense here is to say, you know, to know what the data is today is great, but our solar projects are going to have a lifetime of, let's say, 30 years. 30 years from now, we may have different climate conditions than we do today. If you want to think about what's going to happen to this project over time, one would presumably want to think about the effect of climate change. Are you able to, briefly, is this something that you're able to do? Have you thought about this?
Yes. So thank you for the question. It's really an important question. Just for the forecasting of the solar resource, as I said, there is three time horizons for the short term, the medium term, and the long term. For the long term, we use what we call numerical weather prediction models that are micro-scale models which can simulate all the big scale phenomena, include climate change and other phenomena. We use what we call also global circulation models that have a big spatial and the time resolution. So those phenomena like climate change are of course taken into consideration in our simulations because it's a long-term phenomenon, and the models is able to simulate that type of phenomenon.
Good, thank you. Good. Here's a question I'll put out for everyone, and I'm not sure I completely understand the question, but perhaps you can help out. This person says, what is your view on online weather forecasters in relation to wind and PV, for example, Weather Sentinel? And here I'd like to just clarify our language. Usually when we talk about weather, we're talking about what happened today or tomorrow or next week. When we're talking about climate, we're talking about longer term trends. In looking at the performance of a PV system in the future, we are not so concerned about weather, we're concerned about climate. If we're looking at measurement and verification, we might have been quite interested in what was the weather in the last month. So the question again is your view on weather forecasters in relation to PV, for example, a forecaster named Weather Sentinel. Would anyone like to speak to this?
I can give my opinion.
Thank you.
The databases we are using is a result of multi-year work, right? We have 14 years, 20 years databases that then build up a typical meteorological year. So we are not talking about 1 month or 1 year just. We need to make sure we have a big database, a comprehensive database that can give us at least the trend of the last years.
Yeah. Okay, thank you. I think that speaks again to the difference between climate and weather. Here's a question that perhaps is best for Henrique and maybe Esme. Probably all of you know something. So the regular calibration of weather stations, especially the pyranometers, during the O&M, so operation and maintenance phase, is very important. This person says, what is the industry standard? So this is, how often do you calibrate your pyranometers? He says every 2 years as per pyranometer manufacturer requirements, or every 1 year as per IEC 61724 standard. So pyranometer calibrations, what are you doing? Anybody? Let's start with Esme.
For our case, we do like the pyranometer manufacturer minimum requirements, and we do the calibration every 2 years. So we send the captures to the manufacturer, and he does the calibration at the laboratory.
Great.
So it's every 2 years, yes.
Every 2 years. Anybody else have a want to weigh in on this, Leandro or Henrique?
Same 2 years. Yeah.
2 years. Okay, Henrique.
Yes, it will be the same. So what we usually follow is the normal recommendation from the weather station.
Okay, great. Question for Asmi. When you compare the satellite data to your ground measurements, it's in general terms, how close are you finding the satellite data is? Can you say that there's a certain percentage that you're having to adjust things as you look at ground data, or are the two lining up quite accurately?
when we do the comparison, we found that the satellite database produces a highly correlated GHI and DNI estimates with the in situ measurements, but it's usually systematically overvalued with the grade quality for stations that are in mountainous or humid or with high aerosol concentration areas. So when we did the calibration, the solar atlas had undergone 0.9% correction for GHI and minus 6.6% for the DNI.
Great, good. I think that answers the question. While we're talking about calibration, here's another one. You alluded to this a little bit, but a specific question is, how are the pyranometers calibrated? Many countries don't have laboratories for the instruments. Do you send them back to the manufacturer, which typically is in Europe? Or do you bring in on-site calibration services by a specialized company like GeoSun? Where and how do you calibrate your pyranometers? Let's start with Azmi, since you're already on the screen.
Yes, because we actually send the captures to the laboratory. We do actually laboratory calibration because they simulate perfectly all the climatic and meteorological conditions
Right,
perfectly.
So you send them back. You send them back to the manufacturer. Yep.
Exactly.
Okay.
Yes.
Leandro.
I think that is a common practice, right? The manufacturer will be responsible to calibrate it.
Is anybody doing on-site calibration services by a company like GeoSun? Henrik?
Not in our case. You see, our case is slightly different because we are more kind of the on the buyer side, on the customer side. So we will actually require our EPC or our developer to do that and to give us evidence of that. The way that they chose to do it, it's their choice in the end.
Great. Okay. Good. Question for Leandro. Are you installing your own weather station along with GIS on the ground?
Yeah.
You are, yeah, okay.
We have our meteorological data stations connected to our monitoring system that collects all the meteorological data, and we can cross-check with the expected one. And it's the way we can calculate the PR, because we need to have the energy reaching to the module to then use it on the PR calculation, for example.
There's a question, what is the trend of solar radiation data in a specific area in ME? I presume that means Middle East, for a 5-year horizon. Is it declining or is it increasing? I presume this is a climate change related question. And so in general, would you say that you are finding solar radiation over the years is on a particular site? Is it stable? Is it declining, or is it increasing? Let's start with Azmi.
The trend of the solar radiation in the Middle East.
Yeah.
We can say that maybe it could be declining trend, but actually I don't have any idea about the Middle East solar radiation. But
how about in Morocco?
No, it's at the, as you know, Morocco is situated in the intersection of two oceans, and there is some phenomena that influence the solar radiation, like the the humidity, all the meteorological phenomena. But we can say that it's really an increase in resource. It's really a very good resource in Morocco.
Yeah. Okay. Anybody else want to weigh in on this question? The trend of solar irradiation, level up or down in your geographic area?
I think, to be honest with you, this is a question more likely to be put to the authorities that take care of that. No, from our end, we are just a customer from this for this data. No.
Yeah, fair enough. Interesting question here. Measurements of solar resource data using good sensors is expensive. For a 1 megawatt power plant, how much would you be willing to spend on reliable data acquisition? I'll start with Leandro. A 1 megawatt power plant, how much would you expect to spend? And so I guess the question really is the capital cost of data acquisition as opposed to the ongoing costs. So for 1 megawatt installation, what would you be budgeting for capital expense for data acquisition?
You know that that is a tricky question. On big projects, we have one meteorological data station for 5 megawatts, for example, and then a secondary one for each 5 megawatts over the project. So we have a very comprehensive one, and then several other cheaper, and then that can decrease the cost, but I would say the cost of that would range to 0.5 to 1 cent per watt peak. So if we multiply that by megawatt, we are talking about.
Right. So we're talking about a half a cent to 1 cent per watt you would budget for data acquisition equipment in the capital expense. Yeah, great. The several questions about the presentations. Yes, the presentation is being recorded, and the recording will be available to view in the future. So copies of people's slide sets are not going to be provided particularly, but you can see them on the presentation video, which will be available to review. Here's a simple question. It's a slightly off topic, but I think it's very simple and interesting. A person writing in from Egypt says, in my region, what would you build in terms of DC power versus AC power? It's, of course, frequent to oversize the DC in comparison to the inverter capacity on the AC side. I don't know if you can give a simple answer for somebody in Egypt, but what do you think about when you make that decision? And is there common ratios that you might say are typical for Egypt or other regions? Leandro, I'll put that to you.
So the override of the systems were created to make sure we have more production in the initial hours of the day and the late hours of the day. As we know, the peak power is achieved just for a few hours in the day. So the more we can increase the peak power, more time we will have the AC power at the maximum. So we are squaring the curve. We don't have such a round curve. We will have more a square coming to the peak power earlier in the day and until later in the night. That will make the inverters work more time under the red line, under the maximum power. So if we go to a hot country, I would say we need to be careful to override the inverters too much. because they will be running at the maximum for more time with very hot conditions, and the cooling system is very important, otherwise they will burn. If we are talking about Europe, where the climate is moderated, we can do it without any problem, and we can go higher on the over ratio of the system. But I would say there is no specific ratios per country, but we shall pay attention to the climate. If it's too hot, don't override too much the inverters. Otherwise, you have the risk of getting the inverters burning. If it's not too hot, you can push a little bit by the inverters.
Yeah. Henrique, in your projects, are they oversized on DC compared to the inverters or not?
Yes, they are usually oversized, and the factor depends a little bit on the particular project, but I would say a 1.2 to 1.25 ratio is normally what we use.
Great, thank you. Question again about pyronometers for Leandro. At what stage of the project do you install the pyronometers? Generally, and so that's the first part of the question. And then at the design stage, how many years of historical data are you looking at? I think you said 30, but so two questions. When do you install your pyronometers on a project? And at design stage, years of data.
Okay, so we have the great advantage. We are not working on the wind energy, and we don't need to install the nanometers 2 years before to collect those data. We can install the pyrometers only on the construction phase. We install it during construction. We have some projects where we can build a small meteorological station there in the site to measure important things as the soiling, for example, to improve our modeling system, and the radiation, to cross-check with the radiation data we collect from the satellite. But it's difficult to install these prior to the construction because we don't have any security on the site, and we can get easily without the equipment there. So the normal practice is to install the pyrometers and the meteorological data stations during construction and starting operations when the project starts.
Perfect. Okay. Here's a question. Probably any of you could take this on. If we want to check production data in terms of performance ratio, what are the minimum requirements for sensors for a weather station? For measurement and verification purposes, what are the minimum requirements for a weather station that you'd want to have on site? Leonardo, we'll start with you. You're on screen already, and then I'll ask Henrique if he would like to add anything.
Okay, I would say the pyrometers are mandatory to have a very precise calculation of the PR. One very important thing that I realized here is we need to make sure the pyrometers are cleaned, right? Otherwise, we are measuring the soiling, and we are saying to our monitoring system that is everything okay, the modules are performing fantastically, and no, they have the same dust that we have on the pyrometers. So we must make sure we have the pyrometers cleaned, and they are much more accurate than the solar cells, the reference cells. So that's my recommendation.
Great. Henrique, minimum requirements for a weather station?
Yes, I would say that is kind of more or less the same. We also use sometimes, apart from that, of course, the typical temperature sensors and such. There are a few cases where we have been studying also the use of some basic wind sensors also, more to understand what is the flow of the dust and to understand what is the impact of it. But I would say in average it will be more or less similar to what Leandro said.
Yeah, okay, good, thank you. So it's our 1 hour has now concluded. We have 57% participants online, which is fantastic. Many questions that we have not been able to get to. I would like to thank the panelists right now. What we will attempt to do is to leave the Zoom open a little bit not for ongoing discussion, but panelists, if you can go through the questions and type answers to the ones that are particular. Some of the questions are really aimed at particular panelists. Some of them are a little bit off topic, but panelists, if you have the time to type answers to some of those questions, that would be wonderful. I will thank you all, Enrique, Leandro, and Asme. Wonderful presentations. You're all at the top of your game in terms of your knowledge, and it's really exciting to see what's going on. And so with that, I'm going to conclude the formal portion of the webinar. And thank you to participants. I hope you've found it valuable. And please give us your feedback as time goes on. Thank you very much.
Thank you.
Thank you, Ian. Thank you, everybody.
Thank you.
Thank you, Ian. Thank you.
Panelists, what you can do is just you can turn off your cameras and mute your microphones, and then look at the question and answer. Use whatever time you feel you can contribute to type answers to those questions.
Ian, just a quick note to let you know I've answered all of the questions that were directed to me. So if you don't mind, I would be stepping out of the call.
Yep. Thank you so much, Enrique.
Okay, thank you. See you soon. Bye-bye.
Bye-bye.